This is video 5.5.4. We're going to look at more strategies for solving trigonometric equations. These involve using your calculator and solving application questions using what you've learned about solving functions here. So we're going to solve the equation cosine of x is equal to negative 0.437. So this is not on our unit circle. We know that for sure. But we can still find all solutions between 0 and 2 pi. And we could also still describe all solutions that exist for this function in general. The process is the same. The only difference is we're going to use our calculator to ask the question, where is cosine negative 0.437, by using cosine inverse. So we're going to punch into our calculator cosine inverse of negative 0.437. So in my calculator, I'm going to plug in the following. I'm going to make sure that I'm in radian mode. So I'm going to test my mode first. Looks like I'm in radian, so I'm good to go. And I'm going to punch in cosine inverse of negative 0.437. And I get the answer 2.023. I'm going to leave a couple of decimal places just to be a little bit more accurate. 2.023. So I have my solution. I have one of the solutions, but we want to remember that cosine gives answers. The inverse will give answers only in its range. And cosine inverse has a range of 0 to pi. So we have to remember those important facts from chapter 4. Since the range is from 0 to pi, I have been given this answer of 2.02, and that happens to fall somewhere right in here. That is the first solution. I know it falls there because pi is 3.14, and half of pi is about 1.7. So I know that this falls approximately in this second quadrant. Now that's not super important because the process we're going to do will remain the same. So we want to think about this. Cosine, where is cosine negative? Because we want to find the second solution from 0 to 2 pi. And we see that the cosine, and we know the definition of cosine is that it's the x value. So the x value happens to be 2.023 at this point. Now, I'm sorry, it happens to be negative 0.437 at this point. So now I'm going to remember that I can simply reflect. And this angle down here, going to that point on the unit circle, will have the same cosine. It's going to have the same x value at that point. Okay, so this point will be a reflection down of this triangle. And it will have the same exact cosine value. So the question is, how can we describe what the measure of that angle is? Okay, it's going to be, there's a couple of options that you can do here, and I'm going to show you one that will work for sine and for cosine. For cosine every single time, no matter which angle you're given, whether it's a positive cosine or a negative cosine. So the other angle is going to be related by a full circle. So take a look at this here. We went from here forward. So we have that question. That's the angle we're given. That is 2.023. We have to figure out how to go from here all the way down here. So we got to figure out how we got to that point. Well, notice that this angle is identical. This blue angle is identical to this one right here. So if I went backwards, if I wanted a negative angle, this would be pretty simple. I just throw a negative on 2.023. That would be the description of the negative angle that's down here, negative 2.023. Well, this angle that I want is related to the negative 2.023, because if I want the full angle going from 0 in the positive direction all the way to this bottom angle, it would simply be take 2 pi, a full circle, and subtract off this green angle that's down here, because I don't want to go a full circle. I want to stop and not go that extra distance. So I'm going to do 2 pi minus 2.023. This will work for every cosine. So whenever you want to find your second cosine value, think of going backwards in the circle. That's going to be equivalent to your angle you were given, but we're going to do 2 pi minus that answer. So the second solution is 2 pi minus 2.023. And once again, I'm going to need my calculator to help me calculate this. And I'm going to punch it into my calculator, 2 pi minus 2.023. And I get my answer of 4.26. Now, if you're not fully convinced that this is the solution, what we're going to do now is I'm going to plug in and I'm going to ask the calculator, okay, what is the cosine of 4.26? Now, once again, I'm in a round and so on, so it may not be exact, but remember, it should give me the same cosine as my original problem. It should be approximately negative 0.437. So cosine of 4.26, and I get negative 0.437. So it's a simple way to check your answer. If you're not sure if you should subtract or add, always think back to your visuals of your unit circle and or your graphs. So the two solutions in our case are the first one we found using our calculator, and the second solution was the one that we got in green, that was 4.26 when we subtracted the two angles. So these are your solutions, 2.023 and 4.26. There are no other solutions from 0 to 2 pi. This one is rather easy. If we wanted to describe all solutions, we would once again, just like we did before, we'd add on 2 pi n to each of these answers. And that would describe all solutions in case I had an amplitude, a period factor, or a shift or something going on in my function. So you'll see some of those perhaps in class this week. So let's take a look at the next example. Example number 8 is going to start getting us into real life problems, application questions. So this is in your book in case you can't read this very well. It's questions 129 and 130. We're going to use the information to solve these problems. Our cycle of normal breathing takes place every 5 seconds. Velocity of airflow y measured in liters per second after x seconds is modeled by the following function. So those are some important pieces. So every 5 seconds we repeat a breathing cycle. And that's a typical, of course, is we're modeling a real life thing. So within a breathing cycle, the first question we're being asked, other thing we want to notice is the velocity of an airflow is positive when we inhale, negative when we exhale. So we want to make sure we know that as well. 129, within each breathing cycle, when are we inhaling at a rate of 0.3 liter per second? So we're trying to inhale, so we're doing positive. And we want the rate to be 0.3, so that's going to be my y. So I'm going to plug in 0.3 in for y, and I'm going to solve for x. I'm going to solve for the second in time where that happens. So this is just like you did with your project, just like we've been doing in class. We're going to divide both sides by 0.6. We're getting the sine value alone. 0.3 divided by 0.6 is 1/2. Isn't that nice? And we get sine of 2 pi over 5 times x. So this is the point where we have to get rid of the sine function. And of course, the way we're going to do that is by inversing. But in our case, sine of 1/2, where is sine 1/2? We know those two from our unit circle. Sine is 1/2 here at 30 degrees or pi over 6. And it's 1/2 here at 5 pi over 6 or 150 degrees. So my two solutions for the angles are pi over 6 and 5 pi over 6. And of course, we once again want to consider that we could go full circle and still be there. Same thing with the 5 pi over 6, so just like we've been doing in class. But we're not done because that's the angle value, but we have some more work to do because the angle has a period factor here. So 2 pi over 5x needs to equal pi over 6 plus 2 pi n. I'm going to go about doing that same thing over here. And now I'm going to simply solve for x. So how can we quickly get rid of 2 pi over 5x? A simple way to get rid of any fraction is to multiply by the reciprocal. So I'm going to multiply both sides by 5 over 2 pi. And I'm going to do that same thing over here, 5 over 2 pi. Now let's see, when I distribute, when I multiply these two, it's going to be pi over 6 times 5 over 2 pi. I see a couple of good things happening. I see the pi's canceling out. And it looks like I'm going to get 5 over 12. That's just the first term. Now I'm going to do it again. I'm going to distribute this to the second term, and I'm going to get 2 pi n over 1 times 5 over 2 pi. Once again, this is really nice. The 2 pi's will cancel. And I'm going to have plus 5n. Now this should make sense. It should make sense that we are within 5 seconds when we inhale we will have 5 seconds to complete a full cycle. And the cycle, the period factor 5 appears here, the actual period appears here. Because every 5 seconds we're going to be at this same point in our cycle. So that 5 appearing there should sort of make sense to you. And then we're going to do the same process here, timesing everything by 2 pi, 5 over 2 pi, because it's the reciprocal. It's the reciprocal of the fraction I'm trying to get rid of over here. Of course, I need my x. So I'm going to multiply by 5 over 2 pi. I'm going to distribute on this side. On the left, it'll just create x alone. On the right, I'm going to get 25 over 12 plus 5. So these are my 2 answers. I'm going to plug in multiple values of n. Another nice thing is we only want it in each breathing cycle, and a cycle is 5 seconds. We saw that up here. So these are important puzzle pieces to put together when solving these problems. So since this is the growth that we're going to be using and the way we quickly find the values, when n is 0 is the only value I need to consider. Because when n is 1, now I'm after the first breathing cycle, because I'm more than 5 seconds after the start of this cycle. So n equals 0 is the only case you need to consider, and your 2 answers are 25/12 and 5/12. Typically, we might give these answers in decimals, but fractions are fine for me as well. We'll just be prepared to find the correct solution on a multiple choice test. So that's question number 129. Now 130 is very similar. So taking a look at 130, that's going to be one of your checkpoints to get that started and to give it a shot. So question 130 is one of your checkpoints. The big difference here is that we are exhaling at a rate of 0.3. So remember earlier we noticed that our values are going to be negative when we exhale. So our velocity should actually be negative 0.3 liters per second. So you're going to do the same exact process, but you're going to have a different velocity and you're going to end up with different answers. Try also number 5. It's similar to the first example we did in this video. Bring your questions into class and we'll go over them thoroughly.